I'm Rubab, your audio navigator, and I'm going to guide you about a very important topic, that is thermodynamics. Questions are often asked in the exam from here. Generally 1 to 2 marks questions. They could be numerical based or concept based. As you all know, thermodynamics is a very important topic. It decides the fate of a process. So you need to be thorough with all the aspects of thermodynamics, and your concepts for each and every terms and quantities used in thermodynamics should be very clear. So let's start with the laws of thermodynamics. There are 4 laws that are 0th law, 1st law, 2nd law and 3rd law. Now let's start with the first law of thermodynamics, which is about the conservation of energy. And you should be well aware with the terms like isolated system, closed system, internal energy. And what is the mathematical expression of the first law of thermodynamics? And you should know about the terms used in it, like what is internal energy, which can be defined as the kinetic energy associated with the motions of the atoms, or the potential energy stored in the chemical bonds of the molecules, and also by the gravitational energy of the system. What are the various statements given for the law for closed systems? Then also internal energy given for an open system. Now, how is the process defined of transfer of matter between an open system and its surroundings? Then what is an adiabatic process? The mathematical expression defining the adiabatic energy. What are adynamic processes? Then how is the heat transfer defined for exothermic and endothermic reactions? For exothermic reactions, the reaction releases heat. The heat energy has a negative value, and heat is the product of the reaction. While in endothermic reactions, they absorb heat, and heat is a reactant in the reaction, and it is always in positive value. Most of the chemical reactions either give off or absorb heat, but not all chemical reactions do a significant amount of work. By far the most common types of work associated with chemical reactions are electric work, like that in batteries and fuel cells, and the other one is the mechanical work done by an expanding or contracting of gases. So you should also go through that how the first law of equation can be related and considered with the expansion and contraction of gas, where pressure and volume are considered for calculating the amount of work done. But the heat transfer can be called as enthalpy. Then what will be the expression of first law of thermodynamics? So go through that. Then you need to go through Kirchhoff's law, which describes the enthalpy of a reaction's variation with the temperature changes. So you should know about the mathematical expression for that, how it is defined, and what are the terms used, like heat capacity. Then you should also know what are the limitations of Kirchhoff's law, that it is only applied to small temperature changes, because over a larger temperature change the heat capacity is not constant. Then you should also go through the different biochemical applications of this law. It has a lot of applications, as it allows us to predict enthalpy changes at other temperatures by using standard enthalpy data, and also go through some numerical problems related to it. Then what is Hess's law? That is also known as the law of constant heat summation. This law is a manifestation that enthalpy is a state function. Then what is the definition? What is the expression for this law? And you should know about the terms like what is entropy. Then what is Gibbs free energy? This law can be expanded to include changes in entropy and in Gibbs free energy, which are also state functions. So you should know about the expression for them. Then what are the applications of Hess's law? Like they are useful in determination of enthalpies of heats of very slow reactions, heats of formation of unstable intermediates like carbon monoxide and nitric oxide, then heat changes in phase transitions and allotropic transitions, lattice energies of ionic substances by constructing Born-Haber cycles if the electron affinity to form the anion is known, and also helpful in determination of enthalpy of electron affinities using a Born-Haber cycle with a theoretical lattice energy. Your concepts about it should be clear. You should know why it works. Then what are the steps involved in solving enthalpy of combustion problems? For example, like balance the individual equations, then if necessary look up standard enthalpies, then flip equations around if necessary to cancel out terms on opposite sides. Then changing the equation around requires a sign change of the heat of that individual step, and then sum up the individual steps. So you need to go through these steps for solving a problem related to it, and problems related to it could be asked in the exam also. Then what is the standard enthalpy of formation? When the enthalpy of formation is positive, then the reaction will be endothermic. If it's negative, then the reaction would be exothermic. After the first law comes the second law. For that you should know why isn't the first law enough, and what is the second law all about. Then what is entropy? And the entropy of the world only increases and never decreases. How can the reversible and irreversible processes can be defined in terms of entropy? For a reversible process, the entropy of the universe remains constant, and for irreversible, the entropy of the universe will increase. What are the different examples of reversible and irreversible processes? Then who are the major scientists who helped in giving the second law of thermodynamics? Then you should know about the derivation and explanation of second law, how it involves the Gibbs free energy, and on that basis the system could be spontaneous or non-spontaneous or at equilibrium. Go through the different examples related to it. Then what are the different applications of second law? For example, it is useful in the explanation of Earth's age. Then what is Gibbs-Helmholtz equation, which is used for calculating changes in the Gibbs energy for a system as a function of temperature. So for that you need to go through the derivation of the Gibbs-Helmholtz equation and what is the final mathematical expression. And you also need to explore the temperature dependence of Gibbs free energy change for endothermic and exothermic cases. And also what is the pressure dependence of Gibbs free energy change. Then what are the different applications of the Gibbs-Helmholtz equation? For example, it is helpful in calculating the enthalpy of the reaction from the Gibbs free energy change and its variation with temperature at constant pressure, and this is helpful particularly in relation to reversible reactions in electrochemical cells. Then the other application is to calculate the Gibbs free energy change for a reaction at a temperature other than 298 Kelvin. So also helpful in calculating the effect of temperature change on the equilibrium constant Kp. Next you need to go through is Clausius-Clapeyron relationship. Who has given this relationship? What is this equation all about? What is the mathematical expression for it? Then what are the terms used in this expression and what do they stand for? You should know everything in detail. Then how is the derivation done? It could be done from state postulate and also from Gibbs-Duhem relationship. So go through both of these. And it will be said that all known substances in the two-phase region fulfill the Clausius-Clapeyron equation, provides the general validity of the first and second laws of thermodynamics. Then what are the different applications of this? You know how it is useful in chemistry and chemical engineering. It could be helpful in determining the specific latent heat of vaporization or the latent heat of sublimation. Then it is also helpful in meteorology and climatology. So go through these applications in details and also different examples. You need to go through numerical problems as well. Then you need to study about the free energy changes occurring in different systems and processes. First of all, you should know what is Gibbs free energy. That has already been told. To go through this, then what is the free energy of a reaction? How is the change in the free energy of a reaction calculated with the help of a change in enthalpy and change in entropy? Then what is standard state free energy of reaction change, which occurs under standard state conditions, like the partial pressure of any gases involved in the reaction is 0.1 molar Pascal and the concentration of all aqueous solutions are 1 molar. And the temperature generally is 25 degrees Celsius, that is 298 Kelvin. Now what is the mathematical expression for the standard state free energy change of formation? And you should know how the reaction is endothermic or exothermic depending upon the change in the enthalpy, and whether the reaction is endogonic or exergonic, that is non-spontaneous or spontaneous, depending upon the standard state free energy change of formation. So clear your basic concepts regarding these points. And what is the change in free energy at equilibrium? And then how is free energy changes related to temperature? Numerical based problems could come from here, asking whether the given reaction is spontaneous or non-spontaneous with the given energy data. Then you also need to go through that how the free energy changes are related to the equilibrium constants. And you should also be able to tell whether the reactions are spontaneous or non-spontaneous depending upon the given values of free energy change and the equilibrium constants. Then how the cell potentials and the free energy changes are related. Just like the Nernst equation given for the cell potential, standard state cell potentials, likewise standard state free energy changes could also be fitted into that equation. Then what is Trouton's rule? According to this rule, the entropy of vaporization at the boiling point is for all substances approximately 90 joule per mole per Kelvin. Who was the scientist after which it is named? And what is the mathematical expression for that? What are the dimensionless variables associated with it? How is it derived? Then you also need to go through the equilibrium constants and the relationship between the equilibrium constant and free energy change. How the equilibrium constants defined, the expression for that. How is it derived? What are the different types of equilibrium constants? Like cumulative and stepwise formation constants, or the association or dissociation constants, the micro constants, Bronsted constants where the pH are considered, then hydrolysis constants, conditional constants, then gas phase equilibria. How is the thermodynamics related to chemical equilibria? What are the units of gas constants, equilibrium constants? What is the temperature dependence and pressure dependence of the equilibrium constants? What is van 't Hoff equation? And what the relationship between the free energy change, Gibbs free energy change, and the equilibrium constant? We'll go through all these points briefly. After all this comes the third law of thermodynamics. The third law of thermodynamics, which states that the entropy of a perfect crystal at absolute zero is exactly equal to zero. You should know what is absolute zero temperature, what is the minimum energy state. You should also know about the history of the third law of thermodynamics, when and how was it derived, the explanation for the third law of thermodynamics, and then what is the mathematical formulation for this, how is it derived, how are the other terms related to this law, for example absolute zero, specific heat. What is the Fermi-Dirac statistics and Bose-Einstein statistics related to this? Then how is vapor pressure related to this? How could the latent heat of melting be derived by this law? Then what are thermal expansion coefficients and how are they defined with the help of this law? What is the Maxwell relationship? You need to go through all these points in detail. Then what is the importance of third law of thermodynamics? For example, it helps in calculating the thermodynamic properties. It is helpful in measuring chemical affinity. Because of this, it is known as Nernst theorem. And it explains the behavior of solids at very low temperature, and it also helps in analyzing chemical and phase equilibrium. So go through all these points. Your concept should be clear about all these. So that was all about the thermodynamics. You could prepare this section in 2 to 3 days. Plus you also need to practice a lot of numerical problems. And all the concepts should be clear because conceptual questions could also come in the exam. I hope you find these information which I shared useful, and I wish you good luck for exam. Thank you.